Here's a basic explanation of how Merkle trees work. So the first important thing to know is that we can hash data. So if we have some data from a user, we might hash it with a particular hashing algorithm and get some data. And this hashing algorithm is one directional, meaning that it's virtually impossible to reliably move backwards. So we know that that is the foundation of what makes all of our computer security possible. So with that in mind, we have the question of how we can store many pieces of information easily without having to search a whole list of data. Now, this is obviously useful in smart contracts where those operations, like a search operation, equivalence testing for a whole list becomes very costly very quickly, perhaps even literally costly to the end user with gas fees and so forth. So the question is, how can we store many pieces of information into a smart contract easily? And the answer are these Merkle trees. And we'll see that Merkle trees allow us to easily store that information and verify when a user has that information. So the very first step is we have our collection. So these here might be, could be addresses. That's the most common application, but they really could be anything. That could be secrets that we provide the user, or names, anything that we like. However, we want these to be unique to the user and actually secret, so that other people cannot impersonate. So the very first thing that we do is we hash each of these values. So now we'll have new values that are hashed. And remember that we can move in this direction and get the same thing every time. So we can go upwards. If a user has a secret, we can get to what it hashes to. However, we cannot go in reverse reliably. You might get insanely lucky and guess, but that's incredibly difficult, and no computer that exists now can do that. So once we have this, then what we do and how we get this Merkle structure is we hash each of these together. So now we have hashes of hashes. And remember, again, we can go upwards but not backwards. We'll hash these again of a new node, and then we hash these last two together. So now we've hashed all our values into a single root here. And this is, we call this the root of Merkle tree. Now, this is the only thing that needs to be stored on our smart contract. And the reason why is because the user can easily prove that they are in this list through what we call a Merkle proof. And so all that's needed for that is a user has to provide their secret plus, so we'll say that this is our user secret. So then the user only needs to provide that and all of the hashes that contribute to this, to generating the root from this piece in particular. So that would mean that we need this one, because this hashed with this will get us to that. Then we need this one, which hashes with that to get this. then we need this one. So those three together are what's called the proof. And the proof is actually just an array, in this case of 3 values, which are these 3. So then if we pass a function, this is a little bit sloppy notation to put a plus here, so we'll change it to a comma. So if we pass a function, we can easily have a function called verify, which takes these two and then the root. And what we'll do is we'll hash this with each part of that in sequence, and then we'll just compare it to the root and see if it lines up or not. So we see that this verify function allows us to just store the root of the Merkle tree and the code for this function on our smart contract and allow the user to hand us the proof and their secret and easily generate that root.